Hey guys, here are the answers to homework number 2. Check them out. All right, let me go through the problems for you. This is the substitution method of solving a system of equations. In number 1, it is nice because the x already is by itself and it equals 4y. So I can go ahead and take what x equals and I can substitute it into the other equation in place of the x. So instead of 3 times x, I'm going to rewrite this as 3 times 4y. And then I'm going to finish the equation. And now I can solve for y. 3 times 4y would be 12y. And 12y minus y would be 11y equals 70. And I would finish that off by dividing both sides by 11. And I would get y equals 70 elevenths. Which I might make a mixed number at the end. I think I did that on the answer key. And then I would take that number and plug it back in over here. And so x would equal 4 times 70 elevenths. And that would be 280 elevenths. So an acceptable answer would be let me put that in a different color. An acceptable answer would be 280 elevenths for x and 70 elevenths for y. I think when I gave you the answer on the answer key, I made it a mixed number or a decimal. Either of those would be acceptable as well. Number 2. Let's see, number 2 is also nice because the y is already by itself, and it equals 3x minus 4. So I can go ahead and take that and replace it or substitute it into the other equation in place of the y. And I'm going to rewrite the other equation as negative 2x plus 5 times 3x minus 4 equals 19. And so I replaced the y with 3x minus 4, right? And now I can take that equation and solve it for x. I would start by distributing the 5, and that would give me negative 2x plus 15x minus 20. And then combining my like terms here, I get 13x minus 20 equals 19. Of course, I would add 20 to both sides, giving me 13x equals 39. And divide both sides by 13. I get x equals 3. I will substitute that back into the first equation. That would give me y equals, instead of 3 times x, it's going to be 3 times 3 minus 4. That, of course, would be 9 minus 4, which is 5. And so my solution here is the ordered pair x equals 3, y equals 5. In problem 3, this is a nice problem because, again, the y is already by itself. So I can go ahead and take what y equals and substitute it into the other equation in place of the y. I'm going to rewrite the second equation. 2x minus, and instead of minus y, it's going to be minus 4x equals negative 12. And now I can go ahead and simplify that equation. I would combine my like terms over here. 2x minus 4x is negative 2x equals negative 12. And if I divide both sides by negative 2, I would end up with x equals 6. And I can substitute that back into the first equation and get the y value. Y would equal 4 times x, which would be 4 times 6 now, or y would be 24. So my final answer would be x equals 6, y equals 24. And number 4, I'm going to have to do a little work. I do not have a variable by itself. I could either get this x by itself very easily or this y by itself very easily. And I'm going to do the x. So, erase that. All right, so the first thing I'm going to do is I'm going to add 9y to both sides. And that's going to give me x equals negative 10 plus 9y. And now I'm ready to take this amount and substitute it into the other equation in place of the x. So instead of 6 times x, I'm going to have 6 times negative 10 plus 9y plus y equals negative 5. So I've rewritten the second equation after I make the substitution, right? And now I can solve that. I would start by distributing the 6. That would give me negative 60 plus 9y, not plus 9y. How about plus 54y plus y? And then I would combine my like terms, and I would get negative 60 plus 55y equals negative 5. Finally, I would get the y by itself by adding 60 to both sides. That gives me 55y equals 55. And finally, I would divide by 55. And of course, that would give me y equals 1, right? And then I can take that and substitute it back into the first equation, where I would have x equals negative 10 plus 9 times 1. That would be x equals negative 10 plus 9, or x equals negative 1. And so my ordered pair that is a solution to this system would be x equals 1, y equals negative 1. All right? All right, these are the same thing, except after I'm done, I'm supposed to tell whether the system has one solution, no solutions, or infinitely many solutions. But it did ask me to solve it first. So, this one is nice because the y is already by itself. So I will go ahead and substitute that. And I will rewrite this first equation as 6x minus 3. And instead of 3 times y, it's going to be 3 times 2x minus 5 equals 15. Let's go ahead and solve that first equation for x. I will distribute the negative 3. Notice it is a negative 3. That will give me 6x. And negative 3 times 2 is negative 6x. And negative 3 times negative 5 is a positive 15. And finally, when I combine my like terms, 6x minus 6x, those just cancel out, and I end up with 15 equals 15. So when both variables cancel out, and I am left with a true statement, that tells me there are infinitely many solutions, or I'm okay with the abbreviation IMS. In problem number 6, again, it's a nice problem because the y is already by itself, and I can take what y equals and substitute it into the other equation in place of the y. So I'm going to rewrite the second equation as negative 3x plus, and instead of plus y, I'm going to do plus 3x minus 6 equals 6. So I have rewritten the second equation. Let's go ahead and simplify that by combining our like terms. Negative 3x and positive 3x are going to just cancel each other out, and I'm going to be left with negative 6 equals 6. So in problem number 6, I am left with a false statement after the variables canceled themselves out of the problem. And so that tells me that this problem has no solution. Problem number 7 is a story problem. I'm going to want to go ahead and define a couple variables. My variables in this case are going to be x equals, I'm going to use x for student tickets, the number of student tickets, and I'm going to go ahead and make y the adult tickets. Number of adult tickets. Remember that 95% of the time you're going to want your variables to represent the answer to the question. And the question was how many adult tickets and how many student tickets were sold. Alright, I'm ready to write an equation then, and my equation is going to involve, first of all, the fact that they sold 220 tickets. That means if I add together the number of student tickets, that'd be x, plus the number of adult tickets, that's going to add up to the total number of tickets, 220. My other equation is going to deal with the cost. So that's going to also involve these numbers. Student tickets cost $2 each, so 2 times x would be the total cost of all the student tickets. And adult tickets cost $5 each, so 5 times y would be the cost of all the adult tickets. And if I add those together, I get the cost of all the tickets, which apparently is $888. Let me apologize now for choosing bad numbers. This doesn't actually work out like it should, but we're going to finish it off anyway. So the first step here would be to get a variable by itself. I'm going to go ahead and get the x by itself. I'm going to subtract y from both sides and get x equals 220 minus y. And I will then take that amount and I will substitute it in for the x in the second equation. So the second equation, when I rewrite it, would be instead of 2 times x, 2 times 220 minus y plus 5y equals 888. I never write that neatly in class. That's pretty good. Now we can solve that for y. If I distribute the 2, I get 440 minus 2y plus 5y equals 888. And finally, I would combine my like terms and get 440 plus 3y equals 888. Let's go ahead and solve for y now. I would subtract 440 from both sides. That gives me 3y equals, that'd be 8 and 4 and 4. And I would finish it off by dividing by 3. And I would get y equals, and this is where it turns out unfortunate. You know, 3 goes into 450 150 times, so this would be 149 and a third. So that means they sold 149 and a third adult tickets. Not really possible. That should be a whole number, and if you rounded it, I guess that would be okay, but you shouldn't have to round it. That would be impossible. And so then we come over here, and we stick that in for the y value, and we get x equals 220 minus 149 and a third, and so that would be 70 and 2/3. So I think somebody miscounted the money. I think that was the problem. And so finally, I can answer with a therefore statement. And my therefore statement would simply answer this question, right? And I would say, therefore, they sold 70 and 2/3 student tickets and 149 and 1/3 adult tickets. All right. Sorry about the bad numbers. So that brings us to number 8, which is going to be a similar type problem. All right. See, it says the length of a rectangle is 5 more than twice the width. It has a perimeter of 34 centimeters. Find the length and width. All right, so because it says find the length and width, I'm going to use those for my variables. And I'll go ahead and use L for the length and W for the width. And then I need to set up 2 equations using things I know about the length and width. Well, it says here that the length of a rectangle is 5 more than twice the width. So that means that the length is equal to twice the width plus 5. So the length would be 5 more than twice the width. And I also know that it has a perimeter of 34. Well, you find the perimeter of a rectangle by multiplying 2 times the length and 2 times the width and adding them together. Or adding 2 lengths and 2 widths together gives you the perimeter. So I know that twice the length plus twice the width is what equals the perimeter, which is 34. And there's my 2 equations. And this is a nice equation because it's already got the L by itself, so I can go ahead and substitute it in there. And let's make the substitution. So instead of 2 times L, this is going to be 2 times 2W plus 5. And I'll finish the equation plus 2W equals 34. And we can go ahead and solve that now. We would start by distributing the 2 and getting 4W plus 10 plus 2W equals 34. Let's go ahead and combine our like terms here and get 6W plus 10 equals 34. I'm going to run out of space here, aren't I? I would subtract 10 from both sides, giving me 6W equals 24. And then finally, I would divide by 6, and I would get W equals 4. And I can substitute that in up here for the length. And get length is 2 times 4 plus 5. So that would be 13. And finally, I am ready to answer the question. The length is 13, the width is 4. So I would say, therefore, the length is 13 what? Centimeters. And the width is 4 centimeters. All right, finally number 9. Number 9 just wants to see if you understand graphing versus substitution. It says, using a graph, how can you tell when a system of linear equations has no solution? Well, there's no solution when you're graphing if the two equations give you parallel lines. So the lines would be parallel if there's no solution. How about using substitution? How can you tell when a system of linear equations has no solution? Well, we had one of those. Right in number 6, there was no solution because both variables canceled out and I was left with a false statement. So, that is what I would say when both variables cancel out and you are left with a false statement. All right, good luck.